A-level mechanics, vertical motion, we're going to have a look at the equation of the projectile path. We're going to have a look at the projectile path of a particle after it's been launched, assuming that there's no interaction with the air. There's no air resistance and no lift generated. Now we've seen, if a projectile is launched with speed v from the ground at an angle of theta to the horizontal, as shown in the diagram, then x is equal to vt cos theta and y is equal to vt sin theta minus a half gt squared. Now from equation 1 we get t is equal to x divided by v cos theta. And if we substitute that in equation 2, we get y is equal to v into x over v cos theta times sin theta minus a half g times x over v cos theta all squared. In the first term on the right hand side, the v outside the bracket and the v on the bottom inside the bracket cancel, and the sin theta over the cosine theta simplifies to tan theta. So that gives us y equals x tan theta. Now the second term simplifies to gx squared over 2v squared cos squared theta. Now we can split the second term up into gx squared over 2v squared times 1 over cos squared theta. Now the 1 over the cos squared theta can be written as cos squared theta plus sin squared theta. So we can split that fraction up as y equals x tan theta minus g into x squared over 2v squared times cos squared theta over cos squared theta plus sin squared theta over cos squared theta. But cos squared theta over cos squared theta is equal to 1, and sin squared theta over cos squared theta is equal to tan squared theta. So this is the equation of its trajectory and is a quadratic in x and y. It is the equation of an inverted parabola. This is an important equation. Given x, v and theta, we can find y, or given y, v and theta, we can find x. However, one of the most useful applications of this formula is to find the angle of projection to hit a target positioned at the point x, y. Let's see how this is done. Suppose we're given v is equal to 13 meters per second, x is equal to 10, and y is equal to 4, and we take g as 10 meters per second squared. Find the angle of projection. Well, to solve this, we substitute those numbers into our equation. Y equals x tan theta minus gx squared over 2v squared into 1 plus tan squared theta. And that gives us 4 equals 10 tan theta minus 10 times 10 squared over 2 times 13 squared into 1 plus tan squared theta. Now we can simplify it a little by writing t instead of tan theta and multiply both sides by 2 times 13 squared. And that gives us 1352 equals 3380t minus 1000 into 1 minus t squared, which simplifies to 1000t squared minus 3380t plus 2352 equals 0. Well, we can solve this on a calculator or using the formula, but it does actually factorise. It factorises as 5t minus 12 into 200t minus 196 equals 0. So, if 5t minus 12 is equal to 0, then the tangent of theta is 12 over 5. So theta is the inverse tangent of 2.4, which is 67.38 degrees. If 200t minus 196 equals 0, then tangent of theta is equal to 196 over 200, or 98 over 100. In other words, theta is equal to the inverse tangent of 0.98, which is 46.37 degrees. So the angle of projection is 67.4 degrees or 43.4 degrees. Let's have a look at how we can use the equation of the projectile path to solve a problem. In example 1, we're told a particle is projected with a speed of 25 meters per second at an angle of 53 degrees to the horizontal. In part 1, we're asked to find its height when it's travelled a horizontal distance of 30 meters. Well, to solve this, we've got v is 25, theta is 53 degrees, g is 9.8, and x is equal to 30. And we can substitute that into the equation of the projectile path. Y equals x tan theta minus gx squared over 2v squared into 1 plus tan squared theta. So we have y equals 30 times tan 53 minus 9.8 times 30 squared over 2 times 25 squared, all into 1 plus tan squared 53 degrees. And if we put that into a calculator, we get y is equal to 20.329. In other words, y is 20.3 meters. Now in part 2, we're asked to find its height when it's travelled a distance of 45 meters. So we have v is equal to 25, theta is equal to 53, g is 9.8, and x is 45. And substituting that into the equation, we get y equals 45 tan 53 minus 9.8 times 45 squared over 2 times 25 squared, all into 1 plus tan squared 53 degrees, which works out to be 15.8826, and so y is equal to 15.9 meters. Now we can draw the graph of the trajectory. If we start with the equation of the projectile path and substitute in theta is 53, g is 9.8 and v is equal to 25, we have y is equal to x tan 53 minus 9.8x squared over 2 times 25 squared into 1 plus tan squared 53 degrees. And that simplifies to y equals 1.327x minus 0.02165x squared. Now, if we draw the graph of this equation, we can see it's an inverted parabola that passes through 0, 0, 30, 20.3, and 45, 15.9. So it passes through the 2 points we found in the original question. Let's use the projectile path equation to find the launch angle required to hit a particular target. In example 2, we're told a tennis trainer can launch tennis balls with a velocity of 20 meters per second. It's set on the ground and aimed up to hit a target 30 meters away and 5 meters high, as shown in the diagram. In this question, take g as 10 meters per second squared. And the question is, at what angle from the horizontal should it be aimed? Well, to solve this, we have the horizontal distance, x, is equal to 30, and the vertical height of the target, y, is equal to 5. We're taking g as 10, and we're given the initial velocity v is 20. So, substituting into the projectile path equation, we have 5 equals 30 tan theta minus 10 times 30 squared over 2 times 20 squared times 1 plus tan squared theta. Now for short, we can write the letter t instead of tan theta. Our equation now cancels down quite a bit. The 10 times 30 squared over the 2 times 20 squared cancels down to 45 over 4. If we expand the bracket and multiply by 4, that gives us 20 equals 120t minus 45 minus 45t squared. In other words, 45t squared minus 120t plus 65 is equal to 0. And we can divide all the way through by 5 to get 9t squared minus 24t plus 13 is equal to 0. Now that's a quadratic equation. It doesn't factorise, so we can either do it using our calculator or we can use the quadratic formula. T equals minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is 9, b is minus 24, and c is 13. So we can substitute that into the formula, and that simplifies down to t equals 24 plus or minus the square root of 108 over 18. The square root of 108 is 10.3923, and that simplifies to give t, or tan theta, is equal to 1.91068, or tan theta is equal to 0.75598. So if we take the inverse tangent, we get theta is inverse tangent 1.91068, which is 62.3736 degrees, or theta is the inverse tangent of 0.75598, which is 37.0885 degrees. And so we get theta is equal to 37.1 degrees, or theta is equal to 62.4 degrees. Now we can draw the graph of the trajectory when theta is 62.4 degrees, or when theta is equal to 37.1 degrees. And we see in each case it passes through the point 35. Let's try another problem, trying to find the angle of elevation necessary to hit a target. Example 3. An archer is 63 metres from a target which is at a height of 42.5 metres. When he is about to fire an arrow, it's 1.55 metres above the ground. When released, the arrow has a speed of 42 metres per second. At what angle should he fire the arrow? Well, to solve this, we're going to use the trajectory path equation. Now we have x is equal to 63, but let's take the origin at the point where he fires the arrow, so the origin is 1.55 metres above the ground. Now that means the target is 52.5 minus 1.55 metres above the origin, so y is 40.95 metres. Now we've got g is 9.8 and we've got the velocity v is equal to 42 metres per second. So substituting in the equation we get 40.95 equals 63 tan theta minus 9.8 times 63 squared over 2 times 42 squared into 1 plus tan squared theta. Now we can let the letter t stand for tan theta. And also 9.8 times 63 squared over 2 times 42 squared cancels down to 11.025. So that gives us 40.95 equals 63t minus 11.025 into 1 plus t squared, or 40.95 equals 63t minus 11.025 minus 11.025t squared. Well, if we take all the terms onto the left-hand side, that gives us 11.025t squared minus 63t minus 51.975 is equal to 0. And we can multiply all the way through by 40. That gives us 441t squared minus 2520t plus 2079 equals 0. Now we can divide all the way through by 63 to get 7t squared minus 40t plus 33 is equal to 0. Now that's a quadratic equation and we could solve it using a calculator or the formula, but it does in fact factorise as t minus 1 into 7t minus 33 equals 0. So t is equal to 1 or t is equal to 33 over 7. Now if t is equal to 1, then the tangent of theta is equal to 1, which means theta is equal to the inverse tangent of 1, so theta is 45 degrees. If t is 33 over 7, then the tangent of theta is 33 over 7, which means theta is the inverse tangent of 33/7, or theta is equal to 78.0238 degrees. So the answer is he must project the arrow at an angle of 45 degrees or an angle of 78.0 degrees. Now, if we want to draw a graph of the equation above the ground, we can substitute in our values of tan theta, but this time y is the projectile path equation plus 1.55 because the arrow is launched 1.55 meters above the ground. So if tan theta is 1, we have y equals x minus x squared over 180 plus 1.55. And we can draw the graph of that. Or we have tangent of theta is equal to 33/7, so y is equal to 4.71x minus 0.0645x squared plus 1.55, and we can draw the graph of that. And we see in both cases the graph passes through the point 63, 42.5.